We have learned how the electrons are filled inside atom according to Aufbau principle. There were other principles given on the basis of how the filling should happen. What will be the quantum number values? And one of those principles is Pauli's exclusion principle. So, what Pauli's exclusion principle talks about is that no two electron inside atom should have all four quantum number values same. I hope you understand that. Can two students of my class have the same address? No. Quantum numbers tell us about the address of electrons. So, as two students of my class cannot have the same address unless they are siblings, of course. I am assuming they are not the siblings. So, two electrons of an atom cannot have all four quantum number values same. So, two electrons of an atom cannot have exactly the complete address same. So, maximum three quantum number values could be same, but the fourth quantum number value has to be a different one. It can be they have different orbits, it can be they have different subshells, it can be they have different orbitals, alright. But out of four quantum number values, as the Muttal principle magnetic spin quantum number values, something has to be different. All four quantum number values cannot be same for two different electrons. That is what Pauli exclusion principle talks about. And the next we are going to talk about is Hund's exclusion principle. What Hund's rule of maximum multiplicity or Hund's exclusion principle talks about is that two electrons, when they get paired, they will get paired only and only when same subshell has one electron with the parallel spin in all orbitals. What does that mean? Let me explain it to you. If we have a configuration 2p5, then what are the possibilities how you can arrange? 2p subshell has three orbitals. What you can do is you can put 1 and 2, 2 like this and like this. Alright. So in 2p5 orbitals, you are putting it like that, but this is not the right way. How it should be? It should be if it is 2p5, then what you need to do is you have to fill it like this: first electron, then second electron, then third electron, then fourth electron will get paired. When each orbital has one electron, then the pairing will start. So when three are filled, now fourth electron will be paired like that, fifth will be paired like that. Pairing will not happen until each orbital of the same subshell has one unpaired electron. Pairing will start only when each orbital has one unpaired electron with the parallel spin. For example, in 3d6, how you can arrange? The subshell has 5 orbitals, alright. So you can do it like this: 2 electrons, 2 electrons. What do you think? This is right? No, this is not the right way. How you have to do? Each orbital should have one unpaired electron, one unpaired, one unpaired, one unpaired, one unpaired, one. 5 electrons are unpaired when all each orbital has one unpaired electron, then pairing will start. Now 6th electron will go like that. So you will get 4 unpaired electron and 2 paired electron. 4 unpaired electron and 2 paired electron. That is what Hund's rule of maximum multiplicity says. Pairing will not happen until each orbital has one unpaired electron with the parallel spin. Next, exceptional configuration has been found in chromium and copper. So chromium, the configuration is 4s1 3d5. What was expected? 4s2 3d4, because chromium has atomic number of 24. But instead of 4s2 3d4, its configuration what was found out was 4s1 3d5. Similarly, for copper, atomic number 29, the configuration expected was 4s2 3d9, but actual configuration was 4s1 3d9, 3d10. So copper has 4s1 3d10, chromium has 4s1 3d5. Why this has happened? Why this has happened? This has happened due to two reasons. First, half filled subshells are more stable than partially filled subshells. So 4s1 3d5 configuration is more stable than 4s2 3d4. 3d4 partially filled. 3d5 half filled. So 4s1 3d5 has been accepted for chromium, and for copper 4s2 3d9 or 4s1 3d10. 4s1 3d10 has been accepted because 4s1 is half filled, 3d10 is fully filled. So what is the stability order? Fully filled, then half filled, then partially filled. So half filled substances are more stable. Because of that chromium and copper have been found as exception. And the second reason is, first is symmetry, stability, and the second reason is greater release of exchange energy. Because if when copper is 4s1 3d10, alright, when 4s1 3d10 and the chromium is 4s1 3d5, the greater release of exchange energy have been found in chromium, because the ways of exchanges have been found out to be 10 ways. So jump of electron is more in 4s1 3d5 instead of 4s2 3d4. So because of that chromium has a special configuration 4s1 3d5.